So let's start today's session. In the last session, we had the overall review of our course. So we got to know the overall structure of our course, the mode of conduct, the textbooks that we are going to use, the kinds of assignments or the nature of assignments and assessment. And finally, we had a discussion about few important terminologies. Those are related to ML or the various domains related to domain. So we have gone through the concept of machine learning and data science, and we had a discussion how machine learning is different than data science. So we have gone through an example and we tried to understand how these two terms are actually different. So in short, machine learning tries to map some data with some other data. So if in this typical example of housing data set, we have seen that if we combine first four columns of this table, then these four columns are actually describing the house. And if we know these properties of a particular house, then it should be possible for us to find out or to predict the price of the house. So in machine learning, we are having such kind of mapping from A to B. Here A is nothing but these first four properties and B is the price. So if I'm using ML, I'm having some kind of a software with me, maybe a mobile application, a website or something like that. And by making use of that application, if anybody inputs this A, that is the input provided to the system, it is possible for the person to identify or to predict the price of the house. So this is how the machine learning system works. It is a kind of mapping between the parameters. Whereas in data science, what we do is we try to get some kinds of insights after analyzing the data. So what we mean by that is actually if we are talking about the same data, then after analyzing this data, what kind of insight we may have. After going through or after analyzing huge amount of data of such kind, it is possible for us to come up with the insight. Like homes with 3 bedrooms are more expensive than homes with 2 bedrooms, even though the square footage or the size of the house is same. So this is one insight. So such kinds of insights actually help the people to take some business decisions. So that is the difference in machine learning and data science. Also, we have touched few of the terms artificial intelligence, and we stated that any method that tries to replicate the results of some aspect of human cognition are artificial intelligence. We talked about machine learning also, programs that perform better with experience. Artificial neural network, it is a kind of machine learning algorithm. And then we talked about deep learning. So deep learning is a type of ANN. So this is the broad way of understanding the meanings of all those terms related to machine learning. And also we have shown diagrammatically where all these different areas stand and how these areas are related to one another. So I hope you have understood till this. So today we are going to see now the entire syllabus or the curriculum, what we are actually going to learn in this course. So we are having the syllabus divided into 6 units. So we are having unit number 1 that deals with introduction. So in this introduction unit, we'll be focusing upon the definition, formal definition of machine learning, applications of machine learning, history of machine learning, types of learning, some terminologies like hypothesis space, induction bias, and so on. Then we'll be talking about performance evaluation. So if any machine learning system is built, it is really very important to find out the performance of that system. So performance evaluation must be there for any kind of system that we are developing. So we'll see how to evaluate the performance of the system, and then we'll be focusing upon the concept of cross-validation. In unit number 2, we are going to look at one of the machine learning algorithms, and that is known as regression algorithm. Also, in this unit, we'll be focusing upon the decision tree algorithm, and that is a kind of classification algorithm. So, in this unit, we are going to focus more upon 2 kinds of regression techniques, simple and multiple regression. Under classification, we'll be looking at logistic regression. So though the term includes regression, logistic regression is a kind of classification algorithm. So we'll be focusing upon that. And the decision tree algorithm, typically the ID3 algorithm. In unit number 3, we are dealing with instance-based learning and feature selection. So in this unit, we are going to cover k-nearest neighbor, distance-weighted nearest neighbor algorithms. Then we'll talk about the curse of dimensionality, and then we'll see how to overcome this curse of dimensionality. And for that, we'll be focusing upon 2 kinds of techniques, feature selection and feature extraction. So we are going to discuss few techniques under feature selection and few techniques under feature extraction. In unit number 4, we are going to deal with probability and Bayes learning. So many of you might be knowing or might be remembering the concepts of probability that you might have learned in your first year or second year of engineering and even in junior college. So we are going to revise the concept of probability and Bayes theorem, and then we'll be focusing upon few important classifiers, Bayes optimal classifier and naive Bayes classifier. In unit number 5, we are going to cover support vector machines and neural network. So this unit is a bit lengthy because we are going to have 2 different kinds of algorithms in one unit. So in detail, we are going to discuss SVM or the support vector machine and how SVM can be used effectively for classification tasks. Further, we are going to neural networks, wherein we are going to focus upon perceptron, which is a simple neural network unit, then perceptron learning, multi-layer neural networks, the backpropagation algorithm, and we'll be having a small introduction to deep neural network. In the last unit, 6th unit, we are going to touch the concept of clustering. So we'll see what we mean by clustering, and we'll be focusing upon 2 techniques under clustering, k-means clustering and hierarchical clustering. If you look at all those units, we are having 1 bit of every unit, and that is application or case study. So everywhere in each unit, whichever concept that we are going to learn, will be discussing few applications of those algorithms. and also we'll be discussing some case studies. Those would be related to your respective engineering domains. So we'll try to identify such case studies and we'll discuss those case studies with respect to every concept. So this is how we have organized our course, and this is the overall syllabus that you are going to learn under this course. If you have any doubts, please let me know. Any kinds of doubts, please unmute yourself.
Hello, ma'am.
Yes,
Ma'am, you gonna share these all PPTs over classroom, right?
yes.
Yeah, that's what I was.
Okay. So, but see, even though I'm sharing you the material, course material, and you are advised to go through that, still I'll recommend that every person will have pen and paper with them, and you should have a habit to note down whatever are the important points those we are discussing, because this will help you a lot whenever once again you go through the provided material,
Yeah,
right? So have that kind of a habit.
yeah, ma'am.
Anything else?
No,
So may I proceed?
yeah, ma'am.
Okay, thank you. So with this now, we know actually what we are going to study in this course of machine learning. So let us begin with the very first unit, and that is introduction. So in the earlier class and also today, we have gone through the terms like AI, machine learning, data science, ANN, and also deep learning. So we are having some idea about all those terms. And now what we are going to discuss in this unit, as I mentioned earlier also, we'll first introduce machine learning, then applications, history of machine learning, types of learning, terminologies, performance evaluation, and cross-validation. So these are the important points, those we are going to discuss. So let's begin with what is machine learning. So by referring to the Wikipedia, we are having the definition of machine learning here. So machine learning is a branch of artificial intelligence that concerns the construction and study of systems that can learn from data. So whatever discussions we had so far, you must have understood that if we would like to build any kind of machine learning system, we should have significant amount of data. And what we mean by data or data set, it is actually whatever may be our problem statement, the some kinds of facts related to the objects in that particular system that we need to collect. And if we are having such facts collected together with respect to the entities or the objects related to our problem, then we say that it is a data set. So most important thing in machine learning is we should have the significant amount of data so that our machine can learn from that data. So according to Wikipedia, once again I am repeating the definition. Machine learning is a branch of artificial intelligence that concerns the construction and study of systems that can learn from data. Now, later, we are going to have a formal definition, or rather few more definitions of machine learning. But before that, let us go through the machine learning paradigm. So all of us, we are aware of classical programming, right? So you have learned C, C++ or some programming language, okay? So that is kind of a classical programming. So what we do in classical programming typically, in classical programming, we are having some set of data, and also we are having certain rules. Those we would like to apply on that data. And our classical programming system is actually providing us some results or answers. So this is a straightforward way how the classical programming techniques work. So once again I am repeating, in classical programming what we have is, we are having some kind of data available with us. We are having the rules, those we would like to impose upon that data, and my classical programming unit will impose those rules on the data, and according to the rules, whatever may be the result or the answers, those are provided to the user. So this is how my classical programming approach works. So let me give you one example. Suppose we would like to identify, or we would like to detect the spam emails. You might be knowing what are spam emails. So actually the spam emails are the irrelevant or illegal messages or emails. Those are sent over the internet and typically to the large number of users. So it is really very important to segregate our emails or to identify whichever is the email that is spam and whichever is non-spam. So let us assume that we would like to use classical programming technique to detect the spam emails. Right? Have you understood what we are trying to do?
Sorry, ma'am, your voice is not audible for the spam mails. Can you repeat?
Okay, okay. Am I audible now?
Ah, ma'am.
Okay, right. So we are supposed to provide the solution for detecting the spam mails. What are spam mails? Spam mails are the irrelevant emails or illegal messages. Those are sent over the internet, and typically such kinds of spam mails are sent to the large number of users, and the purpose behind sending such spam mails is advertising, maybe the phishing, or spreading some kind of malware for some adverse purposes, right? So these are the spam mails, and we do not want such spam mails in our inbox, and that is why it is a classical problem actually to detect the spam mails or to identify the spam mails. So if we would like to solve this problem with classical programming techniques, how we are going to do that? Any idea? Please speak up. Just I mentioned what we mean by classical programming, right? So classical programming accepts data. Hello? Am I audible?
Yes, ma'am.
Yes, ma'am.
Okay. So please unmute yourself, whoever are, there is some kind of a noise in the background. Those who would like to answer my question, please unmute yourself and answer my question. Otherwise, be on mute. Okay, so we want to detect the spam emails and we are making use of classical programming. So what we have in classical programming, some data and rules. Those we need to apply on that data and we need to come up with the answers. So in our problem that we are supposed to solve, what we have? We are having the data. And what is that data? That data is the set of emails. Am I correct?
Yes, ma'am.
Data is set of emails, right? And what is the expected answer? We want to find out whether that email is spam or not spam. And we are making use of classical programming. So obviously, what we need to do is, we need to impose certain rules to check whether the email is spam or not spam. Am I correct?
Yes, ma'am.
Yes,
So,
ma'am.
for example, what kinds of rules now we may have? So, we may have the rules like if the email talks about money or somewhere in between, if the email text contains the dollar sign or something related to currency, or if the email is talking about like you are the winner of something, you have got or you have won the jackpot, something like that. So if we are having such kind of a text in our emails, then there is a possibility that this email is a spam email, right? So while imposing the rules, we need to list out all such kinds of possibilities. Those may result in deciding whether the email is spam or not spam. And after checking out all those rules with respect to the data, that is the set of emails, it would be possible for us to find out whether the email is spam. Right? Are you getting me?
Yes, ma'am.
Yes, ma'am.
Fine. So let us proceed now. So this was related to the classical programming approach. Now we would like to talk on the machine learning approach. So in contrast with classical programming approach, in machine learning, what we have is, we are providing the input. No doubt we should have the data, but we are going to provide the answers as the data, or rather as the input. So for machine learning systems, we are having data and answers as the input to the system. And what my machine learning system will do, it will provide me the rules. Those are appropriate for a kind of mapping. Like if this is the data, this should be the answer. I'll repeat once again. In machine learning approach, the input is my data and also I'm providing the answers as the input to my machine learning system. And role of my machine learning system is to come up with the rules. Right? So my machine learning system is trying to find some relation between the data provided and the answer, and whatever is that mapping, that is being produced as the rule, and later that rule will be utilized for future predictions. So this is how my machine learning system works. So once again, let us talk about the same example and see how my machine learning system will solve that example or solve that problem. So what was the problem? The problem was identifying the spam mails. Correct? So once again, I am having the same set of emails. Those I am providing as data. Correct? I am having the same set of emails. Those are input to my system. But in addition now, with that set of emails, I am having the answers associated. So what I'll do is, I'll prepare a data set like I'm having one email, and in advance I should know whether that email is spam or not spam. So I know the answer or label for that data also, right? So I'm having the emails along with the answers or the labels, whether the email is spam or not spam. So this kind of a data I'm going to provide to my machine learning system. Now, if I'm having such kind of a data, I'm not at all giving any kind of rule to my machine learning system. So my machine learning system will analyze the data, and my machine learning system will provide me the rule. Right? So my machine learning system will learn out of the labeled data that I have provided as input to my machine learning system, and based on this data my system will learn, and then my system will produce some set of rules, or in machine learning terminology we say that the machine learning systems are building the models. Correct? So my machine learning systems are going to build the models for us based on whatever labeled data that we are providing. Okay? So this is how our machine learning systems will work. So I hope you must have understood the difference between classical programming paradigm and the machine learning paradigm. If you have any doubts, please let me know. Any doubts?
No, ma'am. It's clear.
Yes. So I'll be giving you one more example, right? So suppose we are having a data set of images, right? And the images are, say, for example, of animals. So we are having, say, for example, image of cats, dogs, then horses. We are having images of elephants and so on. So we are having lots of images of the animals, right? Thousands of images. And initially we know the label for that image. So which is that animal that we know. So what we would like to do is, we would like to build a machine learning system that will identify, provided the image as the input, my machine learning system should tell me what that image is, whether it is a dog, whether it is a cat, whether it is an elephant, or whether it is a horse, say for example. So if I want to build such kind of a system, then initially I'll be providing a huge data set wherein I'm having all the images of the animals along with the associated labels. So my machine learning system will use that data to learn something, okay, and after learning that it will provide me some rules, and these rules actually are defining implicitly what, say for example, what a cat looks like, what a dog looks like, or how the horse looks like, something like that. So that would be implicitly built in the model or the rules. Those are being generated by my machine learning unit. So I'm providing the data along with the labels, and my machine learning system will produce the model or the rules. And this is how, if after building such kind of a system, if I present some unknown image to my machine learning unit, then what will happen? My machine learning unit will give me the appropriate label, right? Or the tag for that image, whether it is a cat, whether it is a dog, whether it is a horse, and so on. So this is one more example of how actually, in brief, machine learning algorithms or machine learning paradigm works. I hope I'm clear with the concept. If you have any doubts, please let me know, otherwise we'll proceed. I'm not, hello, you are not audible.
Hello.
No, not yet.
Hello. Hello.
Yes, speak loudly. Your voice is low.
Suppose if we give the input other than the previous inputs, then what will be the result?
Previous inputs means the
Previous
data wherein we have not considered that kind of animal, for example.
If we have not considered that kind of animal, and if we give some random animal, then what will be our machine learning
Yes.
system give us?
Yes. So there are, answer to this question is, it depends on whatever approach we are using. Sometimes we are having the approaches like the machine learning system will give me actually the probabilities, right? That describing what is the probability that this particular image is likely to have this label. Say for example, if I am having image that is provided like cat, okay, or dog. So if I am providing input as the cat image, then my machine learning algorithm is actually giving me that there is 80% chance that this image is of cat. Or my machine learning system will provide me that there is only 20% chance that this image is like a cat. Okay, so this is how we are getting sometimes. So it depends on the algorithm that we are using. So if we are having such kinds of probabilities of mentioning the confidence in the label associated, then we may put some threshold, right? And if the threshold is above, say 50%, 60%, whatever it may be, then we confirm that this belongs to that class. Otherwise, we'll have a separate class that this or it is unknown class. So we do not know what is the class of that image. That is one kind of approach, right? Or sometimes we are not having any mechanism of like unknown class. So in that situation, there are chances that few of the images get misclassified. Misclassified means these are wrongly classified. So it may happen. And actually, if we are having such kinds of misclassification, that is what I mentioned earlier, performance evaluation is. So if I am testing say 100 images, and out of 100 images, say 95 images are being classified correctly and 5 images are not classified correctly, meaning these 5 images are provided with some other labels, then we say that accuracy of my system is 95% and there is 5% error, right? So if I'm providing some image of a class which has not been considered earlier, then there are chances that that image gets misclassified. Or in other cases, in other kinds of algorithms, it may provide us the probability that is low for a particular class. And in that situation, it is possible for us that if the probability or the confidence associated is very low, then we may treat it as unknown class. Whether I have answered your question?
Yes, ma'am.
Okay. Any other thing?
No, ma'am.
So may I proceed now?
Yes, ma'am.
Okay. So let us proceed. Yes? Is there any other question? Okay. So let us proceed now with the next concept, and let us try to find out when actually it is meaningful to use machine learning algorithms. Right? So we are having two paradigms now, those we discussed, the classical programming paradigm and the machine learning paradigm. So when to go for machine learning and when to go for classical programming models. So it is not generally a good idea to use machine learning when you are actually very clear about the rules. So many times it happens that while solving a problem, we are having precisely defined the rules. So we know the rules. The rules are very clear. So for example, if this happens, if this happens, if this happens, then definitely my answer should be say A. If we are having some other set of rules, then the answer should be B, and so on. So if we are having such kind of precise way to define the rules, or if in other words I may say that there is a rule of thumb that if you are having very concise and clear rules, then do not go for machine learning paradigm. Once again, I am repeating. If you are having very clear, precise, concise rules available, there is no much complexity in defining the rules. There is no explosion of having the combinations of several rules. Then you should not think of machine learning approach, but instead you should go with classical programming approach. But as against this, in cases where the experts are not able to explain their expertise. What I mean by that? When experts are not able to explain their expertise, then we should adopt for machine learning. So what we mean by that? Let me give you few examples. Let us see that we are having one task, that is image recognition or speech recognition or driving a car. So these are several applications. So if I ask you, like how you recognize the face, or if I ask you how you are able to understand whatever I am talking right now, or if I ask you how precisely mention how to drive a car, is it possible to answer these questions precisely, or is it possible to define some kinds of rules? Yes. Are you getting me?
Yes, ma'am.
So, if I'm having such kinds of applications or such kinds of tasks, so many times it happens that if you look at a person, you immediately identify that he or she is your friend, right? Maybe the friend has a cap on, maybe the friend is wearing some different outfit, right? Suppose the friend is wearing the glasses now. So even though there is a change in the appearance of a person by some means, it is possible for us to recognize that person. Am I correct?
Yes, ma'am.
So even a child is able to recognize the people, the parents, right? So our brain is so intelligent that our brain actually, even though there are significant changes in the appearance, our brain tries to identify, right, that this person is the same, even though even though there are some changes, right? It is possible for us to identify what I'm actually speaking. We can understand the speech, right? But whenever we look at these tasks, it would be very difficult for us, even though we are experts, it would be very difficult for us to precisely list out the rules to carry out or to undergo these tasks. Do you agree with me?
Yes, ma'am.
Right? So, in all such situations where it is very difficult to list out clearly the rules, or sometimes it may happen that the rules are difficult to extract from the situation, sometimes we may come up with the explosion of combinations of the rules, and then the problem gets more and more complex. So if there is slight amount of increase in the complexity, we come up with lots of rules to represent that complexity. So in such situations wherein we are having lots of complex rules, and it would be very difficult to precisely have the combinations of these kinds of rules, and it would be very difficult to explain actually the processes in terms of the rules, then definitely we should think of machine learning approaches. So to solve all such kinds of problems, we should prefer to go for machine learning approaches instead of the classical programming paradigm. In other situations, whenever the human expertise does not exist, for example, in the situation like hazardous environment, say for example navigation on Mars, right? So it may not be possible to have human expertise in such environments. So once again, to solve the problems of such nature, we should think of machine learning. In some other situations, wherever we need the solutions for very specific cases, say for example, if we are talking about some kind of medicine application, and if we want to treat with a specific treatment for their particular allergies or some specific disease. Then based on the symptoms of that particular patient, sometimes we need to have a specific treatment. Then in such situations also we should think of machine learning approaches. So broadly I have mentioned 3 situations, right, wherein we should think of machine learning approaches rather than classical programming approaches. But as I mentioned, when we should go for classical programming approach, typically the classical programming approach is useful if we are having very clear, concise, precise rules available. Otherwise, we should go for machine learning. Am I clear?
Yes, ma'am.
Okay.
Yes, ma'am.
Fine. So now I think our time is up. So I'll be having one small quiz for you. So I'm sharing the link of the quiz in the chat box and you are supposed to answer those questions. Very small quiz. Okay, very simple quiz. So I'll be sharing the link in the chat box and you need to answer those questions.
Ma'am,